Okay, for centers of triangles. Oops, sorry about that. There we go. All right, so, oh gosh, hold on just a second. I know these pretty well, but okay. Let me find my paper in case I must reference it, because I forget these. There's a lot of vocabulary here. But that is why we will make us a really good note card for this after we get done with these notes, because there's a lot to remember. So we're going to talk about 4 different types of ways to find a center of a triangle. So the first one we're going to talk about is called the circumcenter. And the circumcenter is the intersection of the perpendicular bisectors of the sides of a triangle intersect at a point called the circumcenter. Okay, so perpendicular bisector. Let's talk about what that is. Okay, what do you think it means to bisect something? Okay, to dissect is to take something apart, to like take the guts out. Bisect is similar. You're taking something apart, and bi means two, so 2 equal parts is what you're looking at here. So if you bisect something, you cut it evenly in half. So a perpendicular bisector cuts a side in half. So if you look at, for example, this side right here, it is cut in half right there at point F. You guys have probably not had a ton of geometry stuff because we don't teach geometry as a class. What does it mean that this has 2 little tick marks on it and this has 2 little tick marks? That means they're the same length. And so over here you got 1 tick mark and 1 tick mark. That means those 2 are the same. But not the same as these 2 because they have a different number of tick marks, right? And then over here you got 3 tick marks and 3 tick marks, so those are the same. So what we have here, this side is cut in half by this line right here. And that line is perpendicular, right? So perpendicular means that we form what kind of angle? Right angle. So this piece right here is a perpendicular bisector. This piece right here would be a perpendicular bisector. And this piece right here would be a perpendicular bisector. So all 3 of those are our perpendicular bisectors. And if you make the perpendicular bisectors of all 3 sides, they will always meet at one point. In this case, it is point P, and that is your circumcenter. Okay? The circumcenter has some very specific properties about it. The circumcenter is always equidistant from the vertices of the triangle. Okay? What are the vertices of this triangle? C is a vertex. What's another one? A and B. Let's label those as well. Let's use a different color. So A, B, and C are all vertices, or a single one is called a vertex. Okay, so what it's telling us is that the circumcenter is equidistant from the vertices. That means that point P right here in the middle is the same distance. Let me use a different color. We use purple. So from here to this vertex, right here, from the center to this vertex right here, and from the center to this vertex right here, those are all the same length. I should have been filling out this bottom part as I go. So it asks us to list the different pieces here. First we have to list our perpendicular bisectors. I have those in red right here. To list a line segment, what you'll do is you use the endpoints of the line. So we'll say PF, or you can call it FP, it doesn't matter. And you'll put a little line over top of it. And then you'll have PE. And you'll have PD. The circumcenter we already said was point P. You just name it with a letter. And points are typically given with a capital letter. They usually don't use them lowercase for that. And so I now have to list all of the congruent segments, the segments that are the same length. Raise your hand if you can give me one set of segments that are equal to each other. What you got, Josiah? PB. And then our congruent symbol looks like this. It's an equal sign with a squiggle over top of it. And what would PB be congruent to? Or the same length as? PC. Is there another one that is also congruent to? And PA. So all of those are congruent to each other. We also can have the sides of the midpoint are also give us some congruent segments. So, for example, AF, I should have called that one FA instead of AF, and CF are congruent to each other. Who can give me another set? What you got, Joseph? CE is congruent to what other side? EB. Good. And there's one more. Who else can give me one? Angel, what else is congruent? Okay, let's go through what we've got so far. I've got all my purple lines are congruent to each other. I've got AF and FC, are these two right here are congruent to each other. Then Joseph just gave me CE and EB. That's these two right here. We got one more that's marked congruent. How about over here? A what? Okay, so this point right here cuts that line in half. So it's a D right there. AD is congruent to BD. Okay, so there's a lot going on there in that picture. We can use this to answer questions about triangles when they're given to us. So, I apologize for the fact that this is very fuzzy, but it was fuzzy on what I copied it from. So it is what it is. It makes me feel like I need to get new glasses by looking at it. So, if W is the circumcenter of the triangle, QRS, find each measure. Okay, so if this is the circumcenter, let's mark some things that we know. So W is our circumcenter. which would mean that this line, and this line are our perpendicular bisectors. So that means I'd have a right angle here, a right angle here, and a right angle here. And since they are perpendicular bisectors, what do they do to the lines that they intersect out here on the edge of the triangle? Like QS, what happens to it whenever we drop that perpendicular bisector? They're the same. It cuts this in half. So I'm going to put a little tick mark here and here to remind me that those two are equal to each other. It's going to be the same over here, and right here. Those two are equal to each other. And right here, and right here, those two are equal to each other. Okay? So the first thing it asks us for is RS. So RS would be this entire length right here. How could we find it? Okay? So this number 19 is for RU. What's US? Also 19. So what have we got to do to find RS? Add those together, right? And so we just do 19 plus 19, which is going to give us 38 right here. So we get 38 for RS. All right. Then it asks us for TQ. Who can tell me what they would get for TQ? Okay, Jeremy's saying 16. How do you know? It's half of 32. They gave us the whole side here. We just got to cut it in half, right? Because it's been bisected there. So this would be, QT would be 16. Okay. All right. Then it asks me for WS. Any ideas on WS? Okay. How do you know it's 24? You're right. Very good. All of these sections right here, I didn't mark them earlier, mostly because I was getting so many things marked. All of those sides are equal to each other because they told us that the circumcenter is the same distance from the vertices. So since one of those is 24, they are all 24. So WS is going to be 24. Okay. Let's see. Maya, what do you think about QV right here? It's 21, and we know that because VS is marked as 21, and those two should be equal to each other. All right. Then we've got TW. Now, this is our hardest one yet. TW. That's right here. What is that going to be? Okay, we've got a 90-degree angle right there. But it's not asking us for the angle. It's not 19. It looks about 19. They look pretty close. And they will always tell you the picture's not drawn to scale. So you can't make an assumption that two things are the same just because they look the same. However, if you're desperate and you got to guess, it's not a bad idea because they're usually drawn to scale. So I would say they usually draw it to scale, and this is probably close to 19 here, but we can't rely on it. All right, so this is the hardest one yet because all the other ones have either just been equal to something else, or we might have had to double it or take half of it, right? Very, very simple math. This right here is going to require a little bit more math right here because this side right here is not given to you anywhere else. But look at what we've got right here. I'm going to trace this out in green. Right here we got this side, and this side. What kind of shape does this make? It makes a triangle. Specifically, what kind of triangle? a right triangle. And a right triangle, what do we know is always true about the sides? There's a theorem that you learned, probably starting in like 7th or 8th grade. I used to love to. I would teach Hunter stuff that he had no business knowing whenever he was a little kid about math, just because I wanted him to like come in after school, and when my class was like when I had somebody here, and just for him to like look like he knew how to do high school level math. So I taught him Pythagorean theorem whenever he was like in kindergarten. Not how to do it, just what it was. And one day he came in my room and he did this. Whenever he was in kindergarten. Because what is that? I had only taught him how to say it. He was doing a squared plus b squared equals c squared. But the only thing he knew about a square was a shape because he was in kindergarten. So he put an a in a square and a b in a square and a c in a square. But a squared plus b squared equals c squared is your Pythagorean theorem. It works for right triangles. So in this triangle, what side has to be C? The hypotenuse, the longest side. 24. That's your C. Doesn't matter whether you call that 16 your A or your B. It doesn't matter. So we're going to do 16 squared plus B squared is going to equal 24 squared. Right? And so if we grab our calculator, 16 squared is going to give us 256. And 24 squared is going to give us 576. What do I need to do to finish solving that? I need to subtract that 256. Should have done Pythagorean theorem for review. For warm up. B squared equals 320. Then what do I have to do? Not divide. How do I get rid of a square? Square root. And if I do the square root of 320, I'm going to get that B equals, technically there's a plus or minus, but the negatives make sense whenever you're talking about the length of a side. Not really for this, right? So we're just going to use the positive one, 17.889 if we round that off to 3 places. So TW is 17.889. Those are the hardest ones you'll get for these where you have to do that Pythagorean theorem. All right, and then we've got WV. Let's see if that's a hard one. Yep, WV is going to be another hard one. Because WV is this little piece right here. It's not equivalent to anything, but how could we find it? I haven't used red yet. This right here, what shape have we got? That is a right triangle. With right triangle, we can do a squared plus b squared equals c squared, right? So we can let that be our a, this be our b, this be our c. 24 has to be your c because it's across from your longest side. So 21 squared plus b squared equals 24 squared. And so 21 squared is 441. And we already did 24 squared. It was 576. We'll have to subtract. Run out of room. So our b squared is going to equal 135. And what do we have to do last there? Square root. And the square root of 135 is going to give us 11.619. So we get 11.619. questions? All right. Now let's look at one more. Another thing that they like to do for these is give you like geometry problems with algebra involved. Okay? So they tell you P is the circumcenter of triangle ABC. Find the measure of BC. But notice they didn't mark anything except for these two pieces right here. But if P is the circumcenter right here, that means this line, and this line are our perpendicular bisectors. Which means this side is cut in half, this side is cut in half, and most importantly, this side right here is cut in half. Right. So, what do we know about the length of BE and CE? They're the same, which means I should be able to say 13x minus 51 equals 10x minus 33. Right? I could say those two things are equal because since this is a circumcenter, those are perpendicular bisectors. That cuts that in half. So if I want to solve this equation for x, Kama, what would I do first? Perfect. We'll take away that 10x. That'll give me 3x minus 51 equals negative 33. What comes next, Kama? Add 51. So 3x is going to equal 18. Is that right? Yeah, 18. Okay, and last step, Kama. So x will equal 6. Now, is that my answer? What did the question ask for? It asked for BC. So you have to find this first to be able to find BC. But what we need to do is we need to plug this back in so we can find the length of EC or BC, whichever one you choose to use. And then we'll need to find the length of the whole BC there. So if I plug it, I'm going to choose 10x minus 33 just because it's a little bit easier. Because 10s are easy to multiply. So if I do 10 times 6 minus 33, that will give me 60 minus 33, which will give me 27. So, right, yeah. So this side right here is 27. I could plug back in over here as well, but what's it going to be? 27. So if I'm looking for BC, I just have to double 27, and I'm going to get 54. And that would be my final answer for this. Okay, questions? All right. Let's do our note card one step at a time because I think that will be easier for us. So I'm gonna give everybody. I got some bigger note cards. I'll borrow them from Swisher. Okay. All right. These pictures should be easier to draw. I'm going to put centers of triangles here. And zoom in a little bit. That's showing up okay. All right. So what I'm going to do is kind of make myself like a chart. And I'm going to put a picture of the segment itself. And then I'm going to put a picture of what the center part looks like. So I'm going to do my segment. Over here. And I'm going to do my center over here. So the segment that we're working on here is the perpendicular bisector. So I'm going to draw just like one single perpendicular bisector here to help us like really know what a perpendicular bisector looks like. So you can draw any triangle that you want. Does not really matter. It can look like anything. And for a perpendicular bisector, I'm just going to draw one of them because I think it gets a little crazy when you put them all on there. And then we'll draw the next one where we've got them all. What we need to do for our perpendicular bisector is we need to take one of our sides and we're going to cut it in half. So I'm going to use this bottom side right here. And so if I'm cutting it in half, I'm going to show that I'm going to put like one little tick mark here and one little tick mark here to show those two pieces are equal to each other. And then it's the perpendicular bisector. So this line right here needs to be perpendicular. Okay, and then let's, if you've got a highlighter or want to, I don't really have, let me see if I've got any. I think it helps to have a little color in this. I've got a few, although these have not been used in years, so you might want to borrow one, pass that around until they're gone. You might want to take like one piece. They might not work. They've been in that closet for a while. Let's highlight this line right here. You might have to share, and then we're going to label this as the perpendicular bisector. All right. Now, the center that goes with this is our circumcenter. And we're going to, so now we got to draw a triangle that's got all of the perpendicular bisectors in it. So I'm going to draw a pretty similar triangle over here. It doesn't really matter what your triangle looks like. And if we want to draw the circumcenter, we need to find the midpoint of all of the sides, right? So about right here, the middle of that side. I'd say about right here is the middle of that side. About right here. Might be off a little on that. That might be good. Well, we could actually like draw these perfectly with a ruler and a compass, but we definitely don't have time to do that. And so if those are all the midpoints, I want to mark that. So like this is equal to this. This piece is equal to this piece. And this piece is equal to this piece. Okay, everybody okay here? Okay, so we now want to draw the perpendicular bisectors. This is kind of hard to do because you got to get, it's not that hard to do on this one because this is pretty easy to draw like a perpendicular line. I'm going to draw real light right now because I'm going to erase part of this so it doesn't get so confusing. Now, what you can do is just like turn your paper so that that's like, actually, I don't know if that helps any. What you're wanting to do, though, is like, you want the corner of a piece of paper to like line up perfectly right there. Oh gosh. Mine's going to be a little crazy looking. The circumcenter can be outside of the triangle sometimes. Mine's not going to be, mine's going to be like right on the edge. I'm thinking about quitting and starting over. I'm going to because mine's going to look crazy. All right, if your triangle is not lining up like mine is, mine are going to cross like on the edge of the triangle, which can happen. Let me draw it more like I had my other one, where it's more of a scalene triangle. All right. I was not doing anything wrong. It was going to be right. It was just going to look funny. So I'm starting over. All right, so let me get, yours might be just fine. All right, so I'm going to draw this line right here. It's perpendicular. I've got to, like if I put the corner of a piece of paper right here, this will be a little better. Got that line, and then corner of a piece of paper right here for a right angle. I've got this line, and if you've done it correctly, they should all cross right there at the same point. Sorry, I think I got my brightness up a little bit too much. You can't see that.
Mine looks
okay. So I'm going to highlight like this piece and this piece and this piece. Those are my perpendicular bisectors. Those light lines, they're part of the perpendicular bisector, but a lot of times they won't be drawn in there. You can erase them if you want to make it look a little bit better. So this right here is our circumcenter. And there was one more property that they gave us here, and that was that circumcenter is equidistant from all of the vertices, right? So I'm going to draw in like a dotted line here, a dotted line here, and a dotted line here, and I'm going to write down the circumcenter is equidistant from the vertices. No. So that means a different color here. That's saying like this piece, and this piece are all the same. So I'm going to kind of color code that one there. Alright, while you guys are finishing up on that note card, I want to show you what this looks like over here. So if I put in a triangle here, and this program will let me find the midpoint of each side. And then I'm going to construct a perpendicular line. For each one of these. And then I'm going to tell it to intersect. Okay, and then for the sake of you being able to see this better, I'm going to make it not be lines. So do segment here, segment here, segment here. Okay, let me clean this up so you can see it a little better. I'm going to get rid of this line, this line, this line. I'm going to get rid of all these extra labels here. Okay. This is kind of cool right here, this program, because you can see this will let me move my triangle. Notice, like, I redid my triangle because I didn't want the picture that we drew to have the circumcenter on the outside of the triangle. But if you get like an obtuse triangle, the circumcenter actually ends up being on the outside of the triangle. It's kind of weird. But I can move this around. You can see that circumcenter is the case. I could also do this. Watch this. I'm going to put in these segments from here to here, from here to here, and from here to here. Those three right there. Wonderful. Let's change colors. Okay, red. Let's make this one red and red. Okay, so watch those three red lines. Whenever I move this around, notice that they are like, they're always the same length. In fact, I can even, I think I can measure. their length? Let me drag this over here. So you can see, I want that to let me put this, well, it's, I wish it'd let me put these over here where they're not on top of the triangle. But you can see the length of all of those segments are equal to each other. And if I move it around, their length changes, but it's always equal. Alright, so no matter what I make the triangle look like, those numbers stay the same for that. So that's what we're dealing with here. Okay, let's keep going. Okay, our next one is our in-center. Okay, our in-center, get stuff out of the way, is going to be the angle bisectors of the angles of a triangle intersect at a point called the in-center. So your angle bisectors go with your in-center. The in-center is always equidistant from the sides of the triangle. So if we look at this, it is easy to get these mixed up with perpendicular bisector when you're looking at the picture because they look very similar. But point F right here is definitely perpendicular. Does it cut AC in half? It does not. Okay? So this is not a perpendicular bisector. What we're looking at here, the angle bisectors are BP, CP, and AP. That's the points that are coming together. So the angle bisectors here would be BP, CP, and AP. And our in-center right here would be point P. So when it says the in-center is equidistant from the sides of the triangle, that means the center is the same distance away from the side. And the quickest way to get to the side, I could get to the side several different ways. I could go here or here or here, but the shortest distance to the side is the perpendicular distance, right? So that means this piece, and this piece are all equal to each other. So if we want to list our congruent segments, we would say DP is congruent to EP, and that is congruent to FP. All those sides are congruent. Those are our only sides that are congruent to each other, but we do have some angles that are congruent to each other, right? So it is important to note that angle DAP is congruent to PAF. It didn't ask us for that here, but that's what it means when it has those like single little arcs right there, where here it has double arcs. It means these two are equal to each other. And then here it means that these two are equal to each other. To name an angle, I'm going to put one of these up here just to make sure we know how to name an angle. So like, it didn't ask for it specifically, but if I want to know about this angle right here, how do I name that angle? APD would be wrong. APD would be this angle right here. It's got to be DAP. or you could call it angle PAD. Either one of those are okay. Because whenever you're naming an angle, the vertex of that angle has to be the middle letter. Okay, so it's like you're tracing it. So, DAP. You could also call it BAE. You could use like the different letters on those same lines. Actually, you couldn't do E. You could use B. That would be congruent to, what is the name of the other angle right here? How would I name this bottom angle that this is congruent to? Okay, so this is important because you will mess up big time if you don't know how to name an angle. So I need everybody to turn to your neighbor and tell them what you think the name of this angle right here is. Okay, so talk to your neighbor, tell them what you think it should be. Okay, all right, now somebody tell me what they think it would be. Anyone? Keely, did you guys come up with one? What is it? All right, PAF. If I trace it, PA, there's my vertex. F, that looks good. There's another option. What else could you have said? FAP would also work. Okay, so those two angles are congruent. I could do those for all of the angles here. We won't for the sake of time for that. Okay, so when you're naming an angle, the middle letter is your vertex of the angle for that. All right, let's look at some problems. Okay, so let's think about what we know. It tells me P right here in the middle is the in-center. Okay, that means that you've got the angle bisectors. These three lines are your angle bisectors. So that means that this angle and this angle are congruent to each other. This angle and this angle are congruent to each other. And this angle and this angle are congruent to each other. Okay, so let's just run through what we've got here. MJP. So let's think about it. We're going to trace it. MJP. That's this angle right here. What is the measure of that angle? It's going to be 39. Because these two angles right here are congruent to each other. Okay. The next thing it asks us for is NP, this side right here. Actually, I'm going out of order. Ignore that. Let's go in order. Okay, let's go JKL. So JKL, this is talking about this whole angle right here, right? JKL. Now this is a little harder to find. In fact, it'll be a little easier if we skip down here. Let's skip down here and let's find KLJ first. KLJ is this whole angle right here. What would that be? Okay, how'd you get 56? 28 and 28, because if this is 28, this is also going to be 28. So this is going to be 56 degrees. Okay, so that makes it possible for us to go back and get JKL now. I have to remember something about a triangle. What do we know about the angles of a triangle? There's a certain rule about them. Specifically what they add up to. 180. So let's write that down. The interior angles of a triangle add up to 180 degrees. So, if I look at this big triangle, I know that this is 30, this is 39 and 39. So I could, if I put those together, then that's going to be 78, right? This angle right here is 56, which I didn't write down. Hold on. This is 56 degrees. And so I would know here, this whole angle right here would be 78 degrees. This one's 56 degrees. And I can just do, for this part, I can do 180 minus 78 minus 56. And that, 180 minus 78 minus 56, is going to give me 46 degrees. So that's 46 degrees. Okay, there. All right, then that makes this next part much easier because it asks me for NKP. I'm getting too many colors going here. Here's my purple. NKP. What's this angle going to be right here? That is going to be 23. We just have to cut 46 in half. Okay, so that takes care of a lot of our of all the angles they asked us for. Then they also asked us for some sides. So let me go back to this one I was looking at here. NP. What is that going to be? $13, because this is 13. OP is also 13. All those perpendicular lines are going to be the same, if that's the end center. I don't like that it asked me for KM next. Let's first find KP. So for KP, this line right here, I don't have a side that it's going to be equal to, but this is a right angle. So I can do Pythagorean theorem here. Which side is my hypotenuse in this triangle? Not 30. It's KP. It's the one you're missing. So this one you're going to do 13 squared plus 30 squared equals C squared. And 13 squared plus 30 squared, you can type that whole thing in, you'll get 1069 equals C squared. And then you'll have to square root both sides. And you will get the square root of 1069 is going to be 32.696 for that. And so then what we would have to do, if we want to know Km, which is this piece right here, I just found that this side right here was 32.696. So I'd have to do Pythagorean theorem again over here. This time, 32.696 is my hypotenuse, so I'd have 13 squared plus b squared equals 32.696 squared. That is going to be, let's see, 13 squared is 169 plus b squared equals, that's going to be 1069 if you use the exact decimal. You're going to subtract 169. B squared will equal 900, right? And you will square root both sides, and we'll get 30. Okay, I guess we could have done that without calculating, because those two triangles would have to be the same triangles right there. We don't have time to do PL because I do want to add this to our note card. So let's flip over to our note card. All right, so for our segments, we're going to draw a triangle. And then we just want to draw a line that will cut one of those angles right there in half. I think I'll pick this one. And I'm going to mark this angle and this angle right here congruent to each other. So if you've got a highlighter, if you're highlighting that right there is our angle bisector. Okay, then let's draw ourselves a similar triangle over here. And very lightly, I'm going to draw in a line that like cuts those angles in half. So like this angle is equal to that angle. I don't know if I drew that very well. This angle be equal to this angle. And then we would need to do this last one. So skinny angle over here. And then this angle would be congruent to this angle. And if we do it right, they'll all cross at one point. And I am going to draw in those angle bisector pieces a little bit darker. Not the best. And I'm gonna erase my little lines here. So this right here, that middle point right there, would be our end center. And I'm going to put here the end center is equidistant from the sides. And like I did on the other one, I'm going to put a little star right here. And that means like the length from here to the side. Those are all supposed to be the same. Mine are a little bit off, I'd say, but you freehand draw it. That's the best you can do with it. Alright, so just make sure that your note card is good. If your note card looks good, then you may pack up and go, but you want to make sure you've got it. We will finish this up tomorrow. Finish this up and do some practice with it.